Welcome to our tutorial on improper integrals. Definitions. Improper integral. An improper integral is the limit of a definite integral as at least one endpoint approaches a real number, negative infinity, or infinity. Converging. An improper integral that has a finite area under the curve. A curve with an infinite dimension that is converging still has a finite area. If the solution is something other than infinity or negative infinity, it converges. Diverging. An improper integral that does not have a finite area under the curve. A curve with an infinite dimension that is diverging has an infinite area. If the solution is infinity or negative infinity, it diverges. Upper limit. The limit of the integral when the higher bound is substituted in. Lower limit. The limit of the integral when the lower bound is substituted in. Process. To solve an improper integral, you must first find the integral of the given function. After finding the integral of the function, you must find the limit of the function for both bounds, meaning substituting in each bound separately into the integral. Next, subtract the upper limit from the lower limit. The result of that subtraction is the solution to the improper integral. Now, you may determine whether the improper integral is converging or diverging. Remember the definitions. Example number 1. Given the integral of e to the power of 3x with respect to x from negative infinity to 0. You must first find the integral, which is e to the 3x power over 3 from negative infinity to 0. Now, you must take the limit of e to the 3x power over 3 for both the lower bound, negative infinity, and the upper bound, 0. This yields 0 and 1/3 respectively. Subtract the limit of the lower bound from the limit of the upper bound. This yields 1/3. Because the solution is a finite number, the improper integral is converging, and therefore the solution is 1/3. Example number 2. Given the integral of x over the quantity of x squared plus 1 with respect to x from negative infinity to 0. You must first find the integral, which is 1/2 the natural log of the quantity of x squared plus 1 from negative infinity to 0. Now you find the limit of the lower bound, negative infinity, and the upper bound, 0. This yields negative infinity and 1/2 respectively. Subtract the limit of the lower bound from the limit of the upper bound. This yields negative infinity. Because the solution is infinite, the improper integral is diverging. This demonstrates a curve of given dimensions that has an infinite area.